Today we're going to be talking about rationalizing denominators using conjugates. So why would we have to rationalize a denominator? Well, a fraction, it can't have a radical in the denominator, and if it does, when we do have one, we have to use conjugates to rationalize. So let's start off defining what a conjugate is. A conjugate is a binomial, meaning it has two terms with the same numbers as the denominator, but with opposite signs. And here are two examples. We have 3 plus 3 square root of 3. The conjugate of that would be 3 minus 3 square root of 3. You notice that the two terms are the same. The only thing that changes is the sign. So here's another example. We have 4 minus 2 square root of 3. The conjugate of that would be 4 plus 2 square root of 3. Again, you notice that numbers are the same. The only thing that changes is the sign, the operation between them. So here's a practice problem for you. What is the conjugate of 2 minus 3 radical 3? You should have gotten 2 plus 3 radical 3. What is the conjugate of 4 plus 3 radical 3? You should have gotten 4 minus 3 radical 3. The terms stay the same. The only thing that changes is the sign between them. So let's do our first example. We are going to rationalize the denominator using conjugates. So the first thing I want to look at is my denominator. The conjugate is a binomial with the same terms as the denominator, but with opposite signs. We know we can't keep this radical here, so we need to find our conjugate. So 4 minus 2 radical 3 turns into 4 plus 2 radical 3. We are going to be multiplying these two things together. But if we're going to multiply the denominators together, we also need to multiply the numerators. We don't want our value of the function of our fraction to change. All we want is to rewrite it rationalized. That means rewrite this without the radical at the bottom. That is all we want to do here. So to show my work, I am going to break numerator and denominator up in two different colors to show you the work. So I'm going to do my numerator in green and my denominator in blue. I know that if I were to put these two things back together, it would give me the original fraction. I just want to give myself space to work and colors so you can see my steps. So here is my numerator. And here is my denominator. I'm just going to put denominator. Okay, now I'm going to multiply both numerator and denominator by our conjugate. 4 plus 2 radical 3, 4 plus 2 radical 3. Well, this top one looks a little easier. All we're doing is our distribution. Two times 4 is 8. 2 times 2 is 4. And our radical stays the same because nothing is being multiplied. We multiply the outsides and the insides together. But since there's nothing inside of a radical here, we just leave it as what it is. For this bottom one, it looks a little bit trickier. These are two binomials. We have multiplied binomials by each other before in chapter 3. It just looks a little bit different because in this one we don't have variables. Instead, we have radicals. But we can use the same rules that we've done. We did distribution and we did area model. I'm going to go ahead and use the area model because it's what we practice more with in chapter 3. And remember, it doesn't matter where you position them as long as you keep the binomial together. and 4 plus 2 radical 3. All right, so 4 times 4, 16. 4 times 2 radical 3 is going to be a positive 8 radical 3. 4 times negative 2 radical 3 would give me a negative 8 radical 3. Now this one might look a little tricky, but all we're doing is going to focus on the outside numbers first. So what is negative 2 times positive 2? That would give me a negative 4. And then we're going to look at inside of the radicals. So what is radical 3 times radical 3? That would give me radical 9. Looking at this, I could recognize my like terms. Since both of these have a radical, I can combine those. It's true that this one also has a radical, but this is a 9 and these are both 3s. Therefore, these are like terms and this one is not. So positive 8 minus 8 gives me 0. So those cancel out. And I am left with 16 minus 4 radical 9. Well, I know what the square root of 9 is. That's 3. So I can say 16 minus 4. And instead of the square root of 9, I am going to say 3. So 16 minus 4 times 3 gives me 12. 16 minus 12 gives me 4. So if I take my numerator, which was this, and my denominator, which I simplified to 4, I can combine those two as my fraction. So 8 plus 4 radical 3 over 4. Now you notice that I no longer have a radical at the denominator, which is what I wanted. I wanted to eliminate that. Since I did that, I am almost done. The only reason I'm not done is because I noticed that 4, 4, and 8 all have a GCF of 4. So I'm going to divide each term by 4 to simplify it all of the way. Okay, 8 divided by 4 gives me 2. 4 divided by 4 gives me 1. So that becomes plus the square root of 3. And then 4 divided by 4 is just 1. So my answer is 2 plus radical 3. I am going to zoom out and leave this example for you guys to look at while we work on the next problem. Okay, so here is my second example. The first thing I want to know from you is, what is my conjugate? You should have gotten that my conjugate would be 4 minus 4 square root of 3. And what we do at the bottom, we also need to do at the top. Now, what would you get as your new numerator? As your new numerator, you should have the 4 from your original numerator times the conjugate that you just found. Now, what would your new denominator be? Your new denominator should be 4 plus 4 radical 3 times the conjugate that you found out as well. Now, go ahead and distribute these to find your simplified numerator and your simplified denominator. For your numerator, you should have gotten 16 minus 16 radical 3. For your denominator, you should have gotten negative 32. I used my area model multiplied, Canceled my like terms because they were opposite of one another. I got the square root of 9, which I simplified to 3, multiplied, then subtracted to get negative 32. Combining these two things together, I would get 16 minus 16 radical 3 over negative 32. So again, you notice you no longer have radicals, but you could simplify these terms. I am going to look at negative 32, negative 16, and 16. I'm going to divide each one by a negative 2. You can decide to do a positive 2 if you'd like. I just like the idea of my denominator being positive. So 16 divided by a negative 2 would give me negative 8. Negative 16 divided by a negative 2 would give me a positive 8 radical 3 over 16. I notice now that I could have actually simplified by 16 instead of a 2, but that's okay. I could keep simplifying here again by 8, and that should give me my simplest answer. It's okay you don't get it off on the first try like I did. I made that mistake of just going with 2. But if you keep simplifying, you would get ultimately the same answer of negative 1 plus the square root of 3 over 2. I will give you a couple more examples for you to work on. What is 3 over negative 3 plus 2 radical 2? When you solve that, you should get negative 9 minus 6 radical 2. If you did not get that, you could rewind and watch the last 2 examples. The last example I will give you today is going to be 2 over 3 plus 3 radical 3. And that would give you negative 1 plus radical 3 over 3.